Alrighty, how is it going, astronomy class? How about this weather, am I right? Still no responses? Just like in class? Alright, so what we're gonna do is I'm gonna try and lecture you guys through Kepler's laws of planetary motion. Alright, we'll talk about three of them, and we'll probably dive into detail on the first one, kind of talk about the second one, and then briefly mention the third one. You'll get a little more practice with that one later on in the week. Alright, what I recommend you guys do is pause this video so you guys can take down notes. I don't want to make a video that's like 15 minutes long of me just talking about the stuff. Alright, I'd rather have me just kind of go through it and then you guys can pause it and write stuff down as it's going. Alright, so please take notes because it's going to help you guys with your assignment later on in the week. Alright, so first off, who was Kepler? Alright, Johannes Kepler. Alright, he was alive during the early 1600s, late 1500s, and he was a mathematician and an astronomer. Okay, obviously he helped a lot in the astronomy field, and we're going to take a look at the three major laws that he came up with. Okay, he's from Germany as well. Alright, Kepler's laws. All of these have to do with planetary motion, hence the name Kepler's laws of planetary motion. Okay, so it basically describes how they're moving, okay, around the sun and what some weird coincidences, I guess you could say, that he noticed throughout it. So the first law he came up with was the law of ellipses. The second one was the law of equal areas, and the third one is the law of harmonies. So moving on to Kepler's first law of planetary motion. Alright, so basically the law of ellipses just say planets orbit the sun in an elliptic shape. Okay, so some people might think of a planet's orbit and think that it's a perfect circle. That's not true. An ellipse is basically a squashed circle. So it's almost oval looking. If you guys look at the bottom right over here, you can see the elliptical shape right here. Alright, what I recommend doing right now, if you have a chance, is pause the video and then do the worksheet that I attached to this, because the worksheet for this week's assignment all has to do with kind of what exactly an ellipse is, just so you guys have a better understanding for how it works. Alright, next we have the second law, which is the law of equal areas, which describes the speed at which any given planet will move while orbiting the sun. Okay, so a planet, when it's orbiting the sun, it doesn't move at the same speed. It's changing. Okay, and it changes depending on how close it is to the sun. All right, so two important factors to remember is if a planet is closer to the sun in its orbit, it's going to move faster. If the planet is further from the sun in its orbit, then it's going to move slower. Okay, so the law of equal areas, here's also more like sciencey definition for you guys if you like those. It gets a little more complicated than what I just said, so if this goes in one ear and out the other, it's not that big of a deal. Hopefully it'll kind of sink in after a while, though, through different worksheets and whatnot. Alright, so law of equal areas says an imaginary line, alright, basically between the sun and the planet sweeps out an equal area of space in equal amounts of time. Alright, so if you guys can see my mouse over here, alright, as you can see, here is the yellow, that's the sun, the green is the planet, and the black circle represents its orbit. Alright, like we said for the first law, alright, a planet doesn't orbit in a perfect circle, it's an ellipse, that's why it looks like a squashed circle right here. So, if the planet's orbiting, it gets to this point right here. Alright, from here to here, alright, from this side of the blue triangle to this side of the blue triangle, it'll move slowly. But you can see that this blue triangle, alright, is quite long, so it has a pretty good amount of area. Then let's say it keeps orbiting. Now it's closer to the sun. In order for the area of this triangle to be equal to the area of this triangle, the planet has to move faster, okay? Because you have to count the same amount of time. Alright, if you want, here's another visual over to the right. You can tell that when the planet's closer, it starts moving quicker. And you can tell that the triangle is smaller and thicker. When the planet's further, the planet's moving slower and the triangle's skinnier and longer. But if you measured the area of both of those triangles, they'd be the exact same. All right? I know it's a little confusing, but hopefully it'll start sinking in after a few practice worksheets. All right, here's another kind of picture of the law of equal areas. It has to do with the same exact stuff that I just talked about. All right, and the last one is the law of harmonies. Okay, so the law of harmonies basically says, here's the fancy definition for it, which is the square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of its orbit. You read that, you're probably like, what the heck does that mean? If you like science definitions, you can write that down. If I were you guys, I'd only write down this part right here that says t squared equals r cubed. All right, it's a formula. All right, it's very simple. There's two variables, but it says t equals orbital period, and in parentheses you have the units. All right, what is orbital period? Well, how long it takes something to orbit. The units you would use are Earth years. And then we have R, which stands for distance of orbit, and that's measured in a unit called AU, which stands for astronomical units. All right, so if I were you guys, I just make sure that you'd have the law of harmonies, write down t squared equals r cubed, and then, whoop, that's my bad, and then write down this stuff right here. All right, for this week's assignment, or this day's assignment, you're not going to have to do anything with this, just the worksheet that I attached. All right, later on in the week, though, I'll go through an example problem, so hopefully this makes more sense. All right, if you guys like the lecture, don't forget to comment, like, and subscribe, and have a wonderful day.